Hey guys, this is the Vodcast 7.1 Balancing Chemical Equations. For this unit, we entitled it Putting It All Together because you're going to need to remember lots of things that we've already studied so far in the first couple units this year. A couple things that you're going to need to remember are your diatomic elements, the Brinkelhoff. We're going to be doing FLM, not necessarily in this podcast, but probably 7.2. So we're going to convert. You're going to need to calculate molar mass. Your significant figures is how you're going to express your answers, so all of that's coming back as well. We're also going to be naming and writing formulas, so you're going to need to remember your ions, but not only ionic compounds, we're going to also name molecular compounds, acid compounds, and organic compounds. Just a couple slides of review about chemical equations and chemical reactions. A chemical reaction is a change in composition. So how do we write that? We have reactants on the left side of the equation with an arrow in the middle, and our products are going to be on the right side. One or more substances, our reactants, are going to change into a different substance, which you're going to see are the products on the right-hand side. The atoms are rearranged from the reactant to the products. And for a chemical, specifically chemical reaction to occur, there has to be evidence of a reaction. We studied this in Unit 1. There are 4 different types of evidence for a chemical reaction. You can either have emission or absorption of energy that's either in the form of heat or light. You have a change in color of your system. Evolution of gas, this is either bubbles or something that changed its smell. And the last one is the formation of a precipitate, which is when 2 liquids form into a solid. More about reactions and energy. All reactions involve a change in energy. We've talked about this also, I think, in Unit 1. You can have exothermic and endothermic reactions. Exothermic means our heat is being released. Endothermic, the heat is coming into or it's absorbed into the system. You can have spontaneous and non-spontaneous reactions. Spontaneous reactions occur without the addition of anything extra to the system. Non-spontaneous reactions means you have to start the reaction in some way. If you remember back to the methane bubble demo, we had to spark the reaction to get it started. We had to add some activation energy because the reaction was non-spontaneous. So we had to start the reaction in some kind of way. We had to add energy to it. We had to endothermic. We had to put energy into it for the reaction to actually occur. The last thing down here, it says particles must collide in order for a reaction to occur. If our particles are too far apart, the reaction doesn't occur. Here are your different symbols that we're going to talk about throughout balancing chemical equations. The arrow we know means produces or yields, makes, forms. It goes in between our products and our reactants. If you have this little symbol with the arrow going forward and backwards, that means the reactants can form the products, but the reaction also occurs backwards, and the products can go reverse and actually form into the reactants. Solids are represented by a little S, liquids by an L, and gases with a G. Also, aqueous solutions, AQ stands for aqueous. It means it's a solution. It's been dissolved in water. Then you can have a couple of different things written above your arrow. You can have a temperature reading, which means this is the condition, this is the temperature at which this reaction must take place at a specific temperature. If it's just general heat has to be applied, then we use a triangle. If you have to add a catalyst to your system in order to start it or speed it up, you just put the formula of the catalyst here in place of the X. And if the reaction has to occur at a certain pressure, by writing the atmosphere pressure above the arrow as well. We're going to write equations from words generally. We're going to write them in formulas, so we're going to write our compounds. Again, reactants are on the left, products are on the right. And this podcast specifically, we're going to balance chemical equations. Why do we have to balance chemical equations? Well, we have to follow this law of conservation of mass. Whatever we have in the reactant side, we also have to have in the product side. We can't create anything and we can't destroy anything. For ionic substances, first you have to balance the charge, and then you have to balance the number of particles to get the mass to balance as well. So here's our first example. Liquid ethanol reacts with oxygen gas to form carbon dioxide gas and water. If you go back to your Vodcast handout, the first thing it tells you is to box out your compounds. Why are we boxing out our compounds? Because you can't change the subscripts in here. That would change the actual formula. We can't change our compounds because here's our reaction. Now we just need to balance. So step 1, we box them out. Step 2, it says take an inventory. So under the arrow, I'm going to write every single element that we have. We have carbon, we have hydrogen, and we have oxygen. When you take the initial inventory, how many carbon atoms do I have on the left? I see 2. How many hydrogens? Here's 5 plus 1 more, that would make 6. And how many oxygens? Here's 1 plus 2 more, that would be 3. How many carbons on the product side? 1, 2 hydrogen, 3 oxygen. So now we can see that this reaction is not balanced in terms of carbon or hydrogen, but the oxygens are okay. So what I need to do is add more carbon on the right-hand side. If I have 2 on the left, I also have to have 2 on the right. In order to make this a 2, I put a big coefficient out front, and now I have 2 carbons, I have 2 CO2s, but that also changes my oxygen to 4, plus this one. Now my oxygens are no longer balanced because I have 5. In your instructions, it will also tell you to save hydrogen and oxygen for the end because they can sometimes get tricky. How would I get 6 hydrogens on the right? If I put a 3 out here, 3 times 2, I now get 6. Plus, I changed my oxygens again. This would be 3 oxygens here, and this was 4. 4 plus 3 is 7. My carbons are balanced, my hydrogens are balanced, but now my oxygens are messed up. I now have more oxygens on the product side, so I have to add some back to my reactant side. Here I had 1, and here I get 2. If I need 7 minus 1, that's 6. In order to get 6 here, I just put a 3, and that would make that a total of 7. So my balanced chemical equation, if there's no number here, we'll assume it's 1, is 1 ethanol reacts with 3 oxygen to form 2 carbon dioxides and 3 waters. Ready for example 2? Liquid ammonia, or nitrogen trihydride, reacts with oxygen gas to form nitrogen monoxide gas and water. We're going to do the same thing as before. Box out all of our compounds because we can't change what's inside there. Take the inventory. I have nitrogen, hydrogen, and oxygen. On the reactant side, I have 1 nitrogen, 3 hydrogen, and 2 oxygen. On the product side, I have 1 nitrogen, 2 hydrogen, and 2 oxygen. So you can see here the hydrogens are the things the element that's not balanced. So I have to add more hydrogens on the right-hand side. But if I put a 2 there, that changes it to 4. There's no way I can get this to a 4 because it's in multiples of 3. So sometimes we take the least common multiple, math class, what's the least common multiple of 3 and 2? I got to get them to 6. So for 6 hydrogens, I would need 3 waters, but that would also change my oxygen to 3 plus 1 is 4. And then to balance my hydrogens over here, if I put a 2, that gives me 6. But now my nitrogens are also unbalanced. If I wanted to change my nitrogen, I could put a 2 over here. Now my nitrogens are balanced, but that changes my oxygen to 2 plus 3 would give me 5. If you look at the reactant side, there's no possible way that I can get 5 oxygens because this is always going to give me an even number. So I'm going to try and put a 5 here and see what happens. If I have 5 times 2, that's 10 oxygens. How could I get 10 oxygens on the other side? Well, you can either change your NO, your nitrogen monoxide, or you can change your water, or maybe we actually have to change them both. Here's where it kind of guess and check comes in a little bit. If I change my water, I have to also change this. So what's my next multiple that I could get this guy to? We said that originally it was 6. Let's try and change it to 12. If I get 12 hydrogens, I have to change my coefficient out here to a 6. Then to get 12 hydrogens over here, I would have to change this coefficient to a 4. Now my hydrogens are balanced. How many nitrogens did that change? Now I have 4 nitrogens, 12 hydrogens, and 10 oxygens on the left. On the right-hand side, I have my 12 hydrogens. That's what we changed. But it messed up my oxygen. Here I have 6 plus 2. I had 8. If I wanted to get that to 10, and I want to get my nitrogens to 4, if I change the coefficient to a 4, that gives me 4 nitrogens and 4 plus 6, or 10 waters. They're not all going to have this many steps, but there's a more complicated one for you for an example. So my coefficient's 4, 5, 4, 6. I need 4 ammonias plus 5 oxygens to give me 4 nitrogen monoxides plus 6 water is my balanced equation. Examples 3 through 6 are going to be a little bit different because now we're actually going to have to write out the equation before we start to balance it. It might be a little bit more difficult for you if you forget your ions. Balancing equations practice number 3. Lead 4 oxide. Lead 4 is Pb4 plus, and oxide is O2 minus. So that would be PbO2. And here's where those extra symbols come in. This is a solid. Reacts with means plus. Hydrochloric acid solution, hydroic acid, goes back to ide. Chloride is Cl1 minus, so I have to add 1 hydrogen to that to balance it out. That's also a solution, AQ. To form lead 2 chloride. Lead 2, Pb2 plus, chloride Cl1 minus is PbCl2. That's also a solution, AQ. Plus chlorine. Chlorine's a Brinkelhoff. It's diatomic. Cl2, chlorine's a gas. And water. H2O, water exists when it says water in the liquid phase. Now I have my equation. Now I have to balance it. I go back and take my inventory. Pb, O, H, and Cl. I have 1 lead, 2 oxygen, 1 hydrogen, and 1 chlorine. On this side, I have 1 lead, 2 plus 2 is 4 chlorine, 1 oxygen, 2 hydrogen. Lead's balanced. My oxygen is not. I need more oxygen over here. How many more? I need another 1. So if I put a big 2 out front, I now get 2 oxygens, but that also changed my hydrogen to 4. If I have 4 hydrogen on the right, I need 4 hydrogen on the left, and fortunately for us, that also changes this chlorine to 4. 1, 1, 2, 2, 4, 4, 4, 4. It should be balanced. My ratio is 1 to 4, yields 1 to 1 to 2. Example 4. Liquid propane. Oh no, organic. Prop. Prop tells me something and ane tells me something. Prop tells me there were 3 carbons in the chain. Ane tells me they're single bonded, so my formula would be C3H1, 2, 3, 4, 5, 6, 7, 8. C3H8 liquid, don't forget your other little subscript, burns in, reacts with, oxygen. Oxygen's a diatomic. O2, and oxygen we know is a gas. To produce, here it doesn't tell you. So here's your big hint. Whenever you have anything organic, starting with a carbon or has carbon in it, combusting or burning in oxygen, you always produce the same 2 products. They are carbon dioxide, gas, and water, vapor, or H2O gas. Here's my equation. Now I can balance. I have carbon, hydrogen, and oxygen. On the left side, I have 3 carbons, 8 hydrogens, and 2 oxygens. On the right, I have 1 carbon, 2 hydrogen, and 3 oxygen. If you can, save hydrogen and oxygen for last. There's some other key hints on your Vodcast handout to start with the metals, and if you read the bottom of that, it'll give you a couple more hints. If you need to continue to box out your elements or for your equations, your compounds, feel free to do that. I know I need 3 carbons on the right. 3 carbons, that changed my oxygen. 3 times 2 is 6, plus 1 is 7. My hydrogens are also messed up. I have 8 on the left, I need 8 on the right. So if I put a 4 in front of my water, that gives me 8 hydrogens, plus now I have 4, and this was 6. 4 plus 6 is 10. Carbons balanced, hydrogens balanced. I just need a couple more oxygen on this side. If I need a total of 10, I can put a 5 coefficient out there, and now I'm balanced. 1 propane plus 5 oxygens gives me 3 carbon dioxides and 4 waters. Example number 5. When heated, aluminum, we know, all by itself is a solid, right? Aluminum foil, aluminum cans, reacts with solid copper 2 oxide. Copper is a 2 plus, oxygen's a 2 minus. That's nice. That balances out for us. It's a solid. To produce copper metal, copper all by itself, metals are solids, and aluminum oxide. Aluminum is a 3 plus. Oxide is a 2 minus. You can do your drop-in swaps. Al2O3, and that said solid as well. Balancing these guys out, I have Al, Cu, and O for my inventory. 1 aluminum, 1 copper, 1 oxygen. On the product side, I have 1 copper, 2 aluminum, and 3 oxygen. If I need 2 aluminums on the left because I have 2 on the right, I can put a coefficient of 2 out here, and that changes that. If I need 3 oxygens on the left, the 3 coefficient out here, that also changes my copper to a 3, which I can then update on the right. And I should be balanced with 2 solid aluminums plus 3 copper oxide solid yields 3 solid coppers, and 1, if there's no number here, we assume that it's a 1 coefficient, solid aluminum oxide. Last example, solid potassium oxide. K is a 1 plus. Oxygen is a 2 minus, so it's K2O solid. That's not stable, because in the presence of water vapor, H2O in the vapor form, that's gaseous, what happens? It readily converts into solid potassium hydroxide. Here are ions. Solid potassium, K1 plus. Hydroxide, OH 1 minus. They cancel out. KOH, and that's also a solid. First step, write your equation. Next step, balance. Take your inventory. I have K, O, and H. I have 2 potassiums on the left, 2 oxygens, and 2 hydrogens. On the right, I have 1, 1, 1. This one's nice and easy to update. If I just put a 2 coefficient out here, everything is balanced. So now you can go to your 7.1 Vodcast handout, flip to the back, there's 10 examples. Fortunately, all the equations are written for you, so this is just balancing practice. When you come into class tomorrow or the next day we have class, we'll practice some more of these, writing the equations and then balancing them.